this lesson, we're going to write a polynomial function of least degree given the graph. In this example, we're asked to find a polynomial of least degree having the graph shown below. So step one, we're going to look at the end behavior of the graph, and notice that you see the graph is moving from left to right in an upward motion as a rise. We also see that that is the shape of an odd polynomial function. So we can conclude, yes, that this is an odd polynomial function just based on the behavior. So with an odd polynomial function, in writing the least possible degree, it would have a degree of 3. So the next thing we want to do is we want to look at the x-intercepts, or what we call the zeros of this function, and all you have to do is look at the graph to look and see where the graph touches or passes through the x-axis, so either cross or touch in some way. So we can see here that it will cross at -2, so there's a 0 there. At 4, there's a 0 there, and then again at 6, roughly. So to write those as linear functions, we're going to have to write a 0 of -2 as a linear function. Recall, it's going to be x plus 2. To write 4, x minus 4, and x minus 6. So all we need to do at this point is just to find out what a is. So we can take a point, another point on the graph. Here we see a point of 0, 24 there on the y-intercept. We can actually plug in that ordered pair and identify the value of a for our polynomial function. So recall that everywhere you see an x is where you're going to put in your x value of your given number. In this case, it would be 0. And f of x is the same thing as y, so that's where you're going to plug in the 24. So when you do so, it's going to look like so. Let's go ahead and do the math there of inside the parentheses. We're going to wind up with a 2 times -4 times -6. And what that's going to leave us with is 48. Last step to solving for a is to divide by 48, and a equals 1/2. So putting it all together then, this polynomial function of third degree would be 1/2, and this is writing it in linear factorization form. Times x plus 2 times x minus 4 times x minus 6. Now, if you were asked to write it in standard form, then of course you would need to multiply the binomials and get it to where you have a polynomial, and then multiply that polynomial with 1/2. Okay, but this is written in as linear factors here. Okay, your turn. I want you to determine which polynomial of least degree possible is represented by the graph below. So take a look at all the characteristics of a polynomial function and what's going on there. Identify your linear factors, and the end behavior. Use everything you know to identify the graph. So go ahead and pause the video, and then you can start it back up when you're ready. Okay, so what I see here in terms of the end behavior of the graph itself, the fact that both ends are facing downward, it means that we have here an even polynomial function, and that the coefficient of the leading term is a negative, which means I can already cancel out B and D because there's no way possible that either one of those could be the answer. So next, looking at my zeros, the point where it touches indicates that there's a multiplicity there of 2. The fact that it sort of just touches, it doesn't cross the x-axis. And it does that at -1 and at 1. So if we write that as a linear factor, the one to the left, that's going to be x plus 1 squared, and the one to the right is going to be x minus 1 squared. You can also plug in the ordered pair of 0, -8 into your function without having 8 there. You could put an a outside and then plug it in, and what you're going to get as your output is a -8. And so the correct answer choice then is C, writing polynomial functions.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.